Question 3 asks which of the following graphs represents the graph of y equals x squared minus 2x plus 4. So the equation we've been given, I'm going to rewrite it here, is y equals x squared minus 2x plus 4. So this equation is in the form y equals ax squared plus bx plus c. And what we want to do is get it into the form y equals a times x minus p squared plus q. So when we have p and q, it's really easy to visualize what this graph looks like. So what we want to do is change the form of this equation, and from your notes there's expression or equations given for how these variables correspond to each other. And so just taking from your notes, we know that a in both cases is exactly the same. So a is equal to 1 in this case, because the coefficient on the x squared term is just 1. From your notes, we get the equation that p is equal to negative b over 2a. So plugging in our values for that, b is this term here, this coefficient on the x term. So b is negative 2, so we have a negative 2 on the top. We have a 2 times 1 on the bottom. So this gives positive 2 over 2, and that equals 1. So we have p equals 1. For q, the equation is q equals 4ac minus b squared over 4a. Again, this is just taken straight from your notes. And plugging in our values here, for a we have 1. C is this last term here, 4, with no x in it. And we're subtracting b squared, where we said that b is negative 2, so it's negative 2 squared. And that is all over 4 times 1. So evaluating the top here, we have 4 times 1 times 4 is 16. Negative 2 squared is positive 4, but we keep this minus sign out here, so we have a minus 4 on the top. On the bottom, we just have 4. Continuing this on down here, 16 minus 4 is 12 over 4, and 12 divided by 4 is 3. So we have q is equal to 3. So plugging in these values for p, q, and a into this equation, the form of this equation here, we get the equation y is equal to x minus 1 squared plus 3. And so looking at this now can help us figure out where the vertex of our parabola is. So we know that this value p here is a shift to the left or the right, and when it's negative, it's when p is positive, so you're subtracting from the x, we're shifting our parabola to the right, and we're shifting in this case by 1 unit. So we're looking for an x, or we're looking for our vertex at x equals 1. So in A, our vertex is at x equals 2, so that doesn't work. B looks like it's at x equals 1, C looks like it's x equals 1, so those are possibilities. D is again at x equals 4, it's not going to work. And E is at x equals negative 1, but we know it's moving to the right in this case, so that's not going to work. Looking a little bit more closely at B and C, we can look at our term Q here, and we know that's a shift of the vertex up or down, and when we're adding here, or when Q is positive, we are moving our parabola up. So we've shifted our vertex to the right 1 unit and up 3 units. So Looking at these two options here, we want the one that has a vertex at x equals 1, y equals 3, which is this option here. So C is the right answer.